Hi everyone, welcome back to my channel. So I haven't been doing a lot of videos lately, and that's because of school, but in the last couple of weeks in school we covered a very interesting topic, and I really liked that topic, and that topic was atom. And so I thought, why not do a video about it? So in today's video, we'll be discussing about what an atom is and the atomic structure and a lot more. So stay tuned. So first off, let's answer the first question. What is an atom? An atom is the basic unit of all the material that is around us. So, for example, the camera that's being used to record me right now is made up of atoms. And the book that you read every single day is made up of atoms. All the materials around us are made up of atoms. Okay, so now that we know what atoms are, let's move on to its structure. So before we move on, remember, atoms are really small, and they're made up of even smaller particles. Specifically, there are three particles that make up an atom, and they are protons, neutrons, and electrons. Protons are positively charged, neutrons are neutral, and electrons are negatively charged. Protons and neutrons are always in the middle of an atom. They always clump together. In that clump, it's called a nucleus. So the protons and neutrons are in the center of an atom inside the nucleus. And the electrons orbit around the nucleus in fixed circular paths. Now, after learning about the atomic structure and what an atom is, I thought of two questions. The first one is, what stops the protons from pushing each other away? Because you have to remember that the same forces, what happens is they retract each other. So since protons are all positive and they're all in the nucleus, what stops them from pushing each other away? And the second question that came into my mind was, why do electrons stay in orbit around the nucleus? So let's go ahead and answer the first question. Okay, so why do the protons not retract each other away from the atom? So you have to know that there's actually a force that exists between the neutron and the proton. And that force between the neutron and the proton is called the strong nuclear force. Okay, now that we know that, let's also know it's also good to note that there's the force that makes the protons retract each other and push each other away from themselves. That force is called the electromagnetic force. Okay, so we know there are two forces acting right here. The electromagnetic force and the strong nuclear force. The electromagnetic force is between the protons. It makes the protons retract each other, and the strong nuclear force is between the neutrons and the protons. Now, what does the strong nuclear force do? The strong nuclear force, we know that it's between the protons and the neutrons. What it does is that it makes sure that the protons don't repel each other away. And why? That's because the strong nuclear force is much stronger compared to the electromagnetic force that exists between the protons. Okay, we have answered the first question. Now let's answer the second question. To reiterate what the second question was, it was, why don't the electrons crash into the protons? Okay, in order to answer this question, we've got to back up a little bit, okay? So we know that the nucleus contains the protons and the neutrons. So the neutrons are neutral, the protons are all positively charged, so that's why the nucleus is positively charged. And we know that the electrons are negatively charged. Now, because the electrons are negatively charged and the nucleus is positively charged, right, they both have a different charge. Now, due to the difference in charge, since they both have a different charge, what happens is that they pull each other, and that pull has a name, and it's called the electromagnetic force. Now, due to that electromagnetic force, the electrons in the nucleus, they're pulled together, but they should collide together, right? Because when there's a different charge, right, due to the electromagnetic force, they should collide together, but they're not colliding. Why? Now that's the second question. So let's answer that. Now see, the electrons orbit around the nucleus in a fixed circular path. And when any object is orbiting in a fixed circular path, there's always a force acting on it. And that force is called the centrifugal force. And the centrifugal force, it's in the case of the electron, right? What it does is that it pulls the electron away from the center. But you have to remember, at the same time, the electromagnetic force is pulling the electron towards the center. So both the forces, they're going in opposite direction. The centrifugal force is pulling the electron away from the center, and the electromagnetic force is pulling it towards the center. Now, that's why the electron stays in the fixed circular orbit. That's because, so you have to see why the electron stays in the fixed circular orbit and isn't forced into one of those directions is because both the forces, they're balanced. So because both the centrifugal force, which pulls away from the center, and the electromagnetic force, which pulls towards the center, since both the forces are balanced, that is why the electron stays in a fixed circular path around the nucleus. Okay, now we have answered both the questions that we talked about earlier, and I hope you enjoyed today's video. Remember to subscribe and leave a thumbs up. I'll see you in my next video. Bye!